you everybody for coming out this morning and early. Joining us all wet.
So we are going to present the resume or summary of the traits, session and posters. And I would like to start with the observation that traits are organized at different levels and can be seen either at the plant level when the measurements are on organ or organism level, and then we have these kind of classical plant traits like you probably all know, like specific leaf area, leaf photosynthetic capacity, tree allometry, and something like this. And these are all measured just kind of hands-on in situ. These traits can be upscaled to the ecosystem level, and I've shown an example that the in situ measurement trait community is about to do this. But then on the other hand, there are properties of ecosystems which you could also kind of classify as traits, and we have had a poster to introduce fire traits, which would be kind of remote sensible traits of the ecosystem which relate to fire. And also leaf area index. Probably you can also calculate a leaf area index for a plant, but this does not really make sense. So these are traits at ecosystem level which do not really have a correspondence on the organism level. And what I was not really surprised, but what I really liked in the poster session was there were many posters that did a combination of in situ measurements and remote sensing at all the different levels, from the plant, from the organ to the ecosystem level. And that was a very nice experience for me, being kind of new in this community. The in situ measurement trait community has kind of organized their measurements, or a large fraction of their measurements, and I would just like to highlight that this is a community approach, and it's a second level of data pooling, because maybe I did not mention so clearly that people like Peter Reich, Gary Chapin, Enquist, Crane, they all have compiled data before and then made these data available. Also, major databases that have been developed before are now aggregated. And this is a major step, I think, especially for the community. And then now we have all the different traits, and we have seen that these traits are sufficient to support model parameterization and process improvement. We had two talks which were by Lina Mercado, was directly related to this, and Sebastian Drüssert yesterday, he also corresponded to this. The number of traits is also sufficient to challenge the current implementation of the plant functional type concept, which I have shown here. But my opinion is that the number of data is unfortunately insufficient to support the parameterization and validation of reliable alternatives to a really useful plant functional trait concept. So the research questions that I would see for myself from the trait sessions and posters was, like, there's a clear mandate for the ecological community to provide general trait-environment relationships based on, now that they have all the data in a kind of consolidated way, we should go ahead and do these trait-environment relationships and provide these to the modeling community, so that not the modeling community has to do these analysis themselves. Then, based on this, or in alternative modes, we could provide reliable maps of plant traits on regional to global scale, maybe. In each case, we need uncertainty estimates, because only then these measures could go into kind of assimilation schemes. Then we need to analyze the correlation structure of the many, like about 1,000 different traits, to provide guidance for the development of a maybe more parsimonious DGVMs, like to identify the major axis of plant function. Then there was a clear statement that we need measurements below ground for biomass and traits, and to identify the traits that determine vulnerability and resilience. Currently, most of the traits are related to productivity and respiration maybe, and structure. but what are the traits that determine vulnerability and resilience that will become more important in the future. Then the last research question that I was thinking about was the PFT concept. So there will alternative implementations of the PFT concept, or there will be alternatives to the PFT concept. In the second case, PFTs should become emergent properties of the models. And in both cases, I really appreciated the effort that has been shown yesterday by Ben Poulter to derive plant functional type derived estimates from remote sensing and split these by plant functional types. I think this is very helpful for upscaling of plant traits, but also then for the modeling community. I would hope so. Thank you very much.
So I didn't prepare any slides, but what I would like to add to Jens' discussion was a little bit about how these traits relate to remote sensing and our ability to identify some of them. And pretty much all of the possible traits related to productivity, I think, were identified on various posters: chlorophyll, nitrogen, phosphorus, lignin, tannins, phenols, water, carbon, whatever. And we're still at the point where it's not clear how quantitatively we can retrieve these traits. And I think that, first of all, they don't randomly vary in a plant. The plant has a strategy for light harvesting and for competition and for responding to the environment, sequestering nutrients and so on. So, we ought to be thinking about these in terms of syndromes or, traits that go together. You don't necessarily have to identify perhaps every single one. The other issue from the remote sensing side is that we have pretty much the visible part of the spectrum is dominated by photosynthetic pigments. Okay, so that's a quite strong signal, but the other, and water's a quite a strong signal. I think that there's, for sure we can retrieve those, but when you start talking about phosphorus and say carbon, or nitrogen, you have to deal with the fact that the structure of the plant's also affecting the reflectance you see, and we have to come to terms with how that's affecting the data we measure and how we can account for it. Certainly, LiDAR can be used to help quantify the structure, but we're not going to have LiDAR along with our optical data all the time. So how do we deal with it where we don't have, say, such detailed measurements of structure? At the canopy and ecosystem scale, the additional traits that people brought up in their posters that I think are things we can measure. Obviously, the leaf longevity is something we get out of MODIS or any these time series data sets. But leaf angle distribution turns out to be one that's rather important in a lot of models, and it's not so clear how to. Well, if you have a well-resolved BRDF data set, you could resolve it more easily. But if you're dealing with a more standard MODIS or VIIRS or Landsat data set, it's not so clear how to do it. Some people brought up traits that are related more to ecosystem processes that aren't so related to the plant itself, or maybe more indirectly, Jens mentioned the fire traits, and a lot of those are being measured now by the different fire, response agencies and fire agencies, and so that seems fairly clear within our grasp. But one of the posters by Taraka Davies Bernard brought up they would like to measure canopy interception to better quantify the amount of water that evaporates from the canopy in precipitation events. And maybe that could be it's obviously related to the within gap fraction, and maybe there's some ways to get at that, at least in some high resolution data. So I think in general that many of the things related to plant productivity we can assess, but obviously below ground is going to be more mostly by inference, I think, and competition might also, you can see the consequences of competition, but not necessarily the traits that relate to competition. So I think we need to think more about how can we possibly analyze these data sets to better retrieve the parameters that people want in their process models. So with that, I'll stop and we open it up for discussion. Right? We have 10 minutes for discussion. Yes.
Okay.
Thank you. At your slides survey, and I just wanted you to go back to the one where you used this one, that one there. So it strikes me that at least two approaches, the trait environment relationship approach and the within plant correlation structure approach, they're like competing approaches to how you define traits, really. So like, do you define traits based on the environment, or do you define traits based on each other? And so I think I would add a third aspiration to this list, which would be to assess how the environment affects the correlation structure.
So that's a good suggestion.
So how does temperature affect SLA leaf lifespan relationships? Like, I think that would be really, really useful, because at the moment you're kind of stuck, right? You don't know whether to take a trait environment relationship or just go with a straight trade-off. So that's just a comment. But I like this way you presented this way forward as well.
I would like to add concerning the trade environment relationships. So if you think of the tropics, so strong influence. So normally you have very stable climatic conditions in the tropics, but you can have very different trade compositions at different locations, and we really don't know why. One factor can be, an example, disturbance history and so on. So concerning the tropics, I would guess we need additional ideas to handle with the challenges.
Well, I mean, some of the biodiversity must be, well, it's related to the nutrient status, right? Low nutrient status, and also to the, to herbivory and other pest pressures too. So I mean, there's other things plants are responding to besides directly the climate and the.
I have a question on the how we deal with CO2, because in this trait-environment relationship, of course, you can have a cosmology of a given site, but CO2 is changing with time, and that's most likely is not included in this relationship. So it's kind of challenge, especially for modeling, because then we would need to extrapolate that for the future, this relationship. And I just don't see clearly how we can go, but perhaps with rising CO2 we will also see how this affects competition among species, or how this influences traits in different locations, maybe there are even locations where we would see it in the first place, or kind of hotspots. Do you have any idea on that?
There is a little bit of data on elevated CO2 from elevated CO2 experiments also in the database, but the CO2 is an inherent problem, I think, because whenever you do an elevated CO2 experiment, it's basically a step increase, and the world outside does not see this step increase. And so I have no clear answer that I could give at the moment.
I don't think it would be any more clear if you used plant functional types in your model, how those functional types would respond to elevated CO2 or any other climate change parameter. I mean, you know, you're always going to have additional data besides the remote sensing to drive a model that's dependent on other properties.
My experience is we got to think differently about how these traits work on a mass base versus an area base. Most of our models work on area base, and for example, if I see the leaf traits, the conclusion I draw is that the most productive leaves are thin leaves.
Yes.
And on the mass base, that's because thin leaves are bigger and they absorb more light. If I look at plant traits on an area basis, the most productive leaves are the thick leaves, because they're the upper ones with the most nitrogen. And so I think we need to translate back and forth better, because the modelers, I think, need area-based traits, and I think a lot of the work is done, because it's easy to take a leaf and weigh it.
Right.
Not all of us have leaf areas meters to measure the area.
I mean, one thing, because the traits seem to relate better to mass than to area, that's also true for the remote sensing data. There's been a number of papers that show much higher correlations on a mass basis than an area basis for, you know, where people do leaf reflectance.
Why?
Yeah, why? I can't think this morning, but I think there is a reason. But it has been reported on a number of different papers over, I don't know, for a long time. Maybe Fred, can you answer this?
My feeling is that it's working better at the area basis.
Oh, you say that, okay. But there's been several papers, there are a number of papers that show better mass space.
I think what's happening is that when you do it at the leaf level, you have a better correlation at mass level. But when you move it to the calculator,
then it's different, That is exactly true, but, you know, the leaf traits are also at a leaf level, right? I mean, the trait data. But it just makes it potentially more directly relatable.
Probably a general question, which in this kind of discussion between the PFT description and the plant trait basis for description of the ecosystem, I wonder if there isn't a third axis. I mean, I don't know how many real ecosystem dynamicists we had in the audience this week, but I have no idea, as a kind of dumb external modeler, whether modeling the behavior of plants is the right thing to concentrate on as much as we are. Is the larger scale dynamics of the ecosystem matter? It obviously matters in the ocean. I think Jens made the point about thinking about ecosystem traits as well. Do we need to think about how we classify depths, complexities of food webs, all this kind of stuff? Does it matter to how these ecosystems are going to respond to disturbance, to management, and to climate change? And if so, do we have to think about how we're going to classify that behavior as well?
Well, in this case, I think we're trying to think about how to relate these properties that we can measure with different remote sensing instruments. So even at food webs, which undoubtedly are important in ecosystems, it's not like it's directly accessible from this kind of data. You have to infer it from the traits you measure. Yeah, Frank.
Yes, I wonder also we are involved in phenotyping experiments, and there is a bit the same type of questions. And one way to tackle the traits is to try to infer some parameter, estimate some of the parameters of the models in a very well controlled environment where you measure not only with remote sensing, but of course with ground measurements, and try to constrain the model and get some estimates of the parameters. Then the question is how to, let's say, scale what you measure locally to the globe. So that's obviously a very important question, but that would be a way to get traits that could be used directly in models.
mean, it all has to do with how you're trying to classify the environment and reduce the variability of the botanical diversity in a way that's accessible from remote sensing to be able to use in models, right? So initially people classified them into biomes or various systems, and then we've moved away from that towards these functional types with the idea they would be more closely related to the climate conditions and be better fit for modeling. So the question is this the trait information that the ecological community, botanical community have collected seems to be a different alternative way to reduce the variability. And so instead of having discrete classes, you have a continuous variation from things that have low productivity to high productivity, and you have variation along that whole axis, and then you have another axis of competition or below ground traits or other number of other ways you could look at it. So that was the reason that it's been thought as this might be a better approach. It's still an idea, really. There's probably 2 or 3 papers on the remote sensing aspect of it.
And with respect to upscaling, and I was kind of not surprised really, but I was happy to see that there was in parallel in situ measurements and kind of remote sensing from the leaf via the plant, via the small ecosystem scale to kind of from satellite remote sensing derived values. So the upscaling from the leaf level and controlled environment would not have to be kind of blind to the globe, but it could be on all the different hierarchical levels, could be complemented by observations as well remotely as in situ. And to my understanding, it's done, not really consistent in one project, but at different projects they are all looking at different kinds and different levels of the complexity.
I think we should move to the next session. So thank you very much.